compound amount equal the principal times 1 plus compound interest rate to the power number of interest periods. Now we can rewrite this equation or this formula as compound amount. This is equivalent to the future value or a future value S equal principal B times 1 plus compound interest rate I to the power number of interest periods N. Actually, we have a lot of issues in terms of N and I. We will go to it after introducing an example for the main equation of learning how to calculate compound amount. So let's start with an example to learn how to use this formula in calculating a compound amount. Example: find the compound amount of $1,000 invested at compound interest rate of 10% for, in terms of time, it's given under two requirements. The first one for 1 year, the second one for 2 years. Okay, so all we have from this example that the compound interest rate is a yearly rate at 10%, and we have B compound or present value equal $1,000, and the required here is the accumulated amount or S. So find the compound amount S is required. Remember that S equal B times 1 plus I to the power N. Here if the term is 1 year, also is T or time, then the compound amount will be S equal 1,000 times 1 plus I 0.10 to the power 1. This gives $1,100. For the second year, or after 2 years, S will given by $1,000 invested at 1 plus 10% to the power 2. This results $1,210. As we see, if the time period increases, the accumulated amount or compound amount, or S, grows faster and faster with respect to the simple interest. This figure reflects the growth of fund amount through time with respect to the type of interest, if simple or compound. In terms of simple interest, you will find that the fund amount grows as a linear function. So it looks like a straight line here. So this reflects simple interest method or type. In terms of compound interest, the fund amount grows exponentially. So increasing of fund amount under compound interest type, this is actually a mathematical form, looks like a geometric sequence, and this is a second phase for the exponential growth. So this is compound. Okay, let's write here to distinguish between simple type and compound type of interest. Simple type, if this is time and if this is fund amount or S. So this looks like a straight line function under simple interest type. Under compound interest type, horizontal axis reflect time and vertical axis reflect accumulated amount or compound amount. It looks like a growth under exponential function or exponential curve, or mathematically looks like a geometric sequence. And this is actually reflect the growth of the amount, accumulated amount under compound interest type. It will grow 1,210 here, 1,010, 1,100, 1,200. If you invest this amount more time, you will find that the fund amount or accumulation of the amount will grow faster and faster under the compound interest type. In terms of simple interest, the growth of the amount will be slowly and the distinguish will be appear obviously if n number of interest time periods increase and increase. Returning to our book, you will find here from this figure, you will find that fund amount under simple interest or compound interest concept, the difference or deviation between the fund amount under these two concepts will increase and increase as time increase. Here, horizontal axis, which reflects time, as time increase, see the fund amount under simple interest grows slowly, but under compound interest grows faster and faster. This is also illustrated here in the text. If you have $1,000 invested for only 5 years, you will obtain a fund of $125. But under compound interest, your fund will be 127. So the difference between the two amounts is just $2. But if you continue with this investment for 100 years, what is the result? The fund amount under simple interest just $600, but under compound interest your fund account will be $13,150. So this is also, as mentioned before, illustrated from the graph here, from the figure. As time increase, the deviation or the difference between fund account this deviation will increase as time increase. I'll stop here. See you.